Section 4.3 is about the remainder theorem. The remainder theorem says if a polynomial p of x, so some polynomial, is divided by a binomial is just a two-term polynomial, the remainder is going to be a constant, and then if we were to multiply what we divided by, this is saying we're going to multiply what we divided by what we get, and add our remainder, we'll end up with our original, and that makes sense. But the biggest thing that comes out of this is when we divide, we're going to get a remainder that's a constant at the end, and we're also going to get a polynomial that is 1 degree lower than what we originally started with. So if we started with something like x to the fourth plus 3x cubed minus 2x squared plus x minus 1, and we divide by, say, x plus 2, all right, the polynomial that we get when we do long division is going to be 1 degree less than what we started with. It's going to be an x cubed polynomial. And if we have a remainder, that remainder is going to be a constant at the end. Okay, so moving on to our first example here. And we're going to see where this chapter is leading us and why they're showing us the remainder theorem. And we'll do some different things with the remainder, and we'll find out some different things here. So first of all, they say let our polynomial be 2x cubed plus x squared minus 4x plus 3. And show that if we put -1 into the function, that is going to be the same thing. It's going to be the remainder when we divide it by x plus 1. All right, so they're saying, let's plug in -1 into the function. So 2 times -1 cubed. So we're saying, sorry, p of -1. Plugging in -1 into the function plus -1 squared minus 4 times -1 plus 3. Well, -1 cubed is -1 times 2 is a -2. -1 squared is a +1, so +1. -4 times a -1 is a +4, and then plus 3. So we'll see. -2 plus 1 is -1, plus 4 is 3, plus 3 is 6. So they're saying that this is going to be the same thing. If we plug -1 into the function, and then if we divide it by x plus 1, the remainder is going to be 6. And we're going to test that hypothesis here right now. That's what they want us to show. So what we're going to do is we're going to do our long division that we've worked on. And we have 2x cubed plus x squared minus 4x plus 3. And they want us to divide that by x plus 1. Divide that by x plus 1. All right, so when we do long division, we have to figure out what multiplies. We have to multiply this binomial on the outside by something to get this first term to cancel out. So we have to multiply, what can we multiply by x to get it to be 2x cubed? Well, 2x squared would be that answer. When we multiply this entire binomial by 2x squared, we get 2x cubed plus 2x squared. And the same thing goes, we're still doing long division, so we need to subtract. So when I subtract, I'm going to cross the line and change all of the signs here, and which is good. This is going to cancel out. That's exactly what we want. And then we have x squared plus -2x squared, which gives me a -x squared. And I'm going to bring down my next term. So it's just like using long division on two numbers. Now I need to figure out what multiplies, what we need to multiply x by to get a -x squared, and we know that is going to be minus x. So if I multiply this entire thing by minus x, I'm going to get -x squared minus x. And again, we're subtracting though, so when we subtract, we have to cross the line and change all of the signs. All right, and this is going to cancel out, which we want. -4x plus x is going to be a -3x, and I'm going to bring down my next term, so plus 3. And then we need to figure out what can we multiply x by in order to get it to be a -3x, and we know that that will be -3. So that would be -3x minus 3. And again, we're subtracting though, so when we subtract, we have to cross the sign and cross the line, change all of the signs. This cancels out, and we're left over with a remainder of 6, and that's exactly what they thought we would get. They want us to prove that, and we did. And why did we prove that? Well, we'll see here in a little bit. We'll see where we're going here. All right, and now one thing to notice that we plugged in -1 here. This is x plus 1. That's something to keep in mind. Why is this a -1 and why is this x plus 1? All right, so moving on. Synthetic division, though, before we move on, it's going to be a shortcut to long division. What synthetic division does is it doesn't require us to have so much writing. But what we're going to do in synthetic division, we are going to just deal with the coefficients. And the first thing we have to do is we have to write the coefficients in not the coefficients, we have to write the variables in descending order from biggest degree to smallest degree. So this is already in descending order. So 3 is bigger than 2, which is bigger than 1, which is bigger than 0, right? Okay, and then we have to find what makes the divisor 0. That's where this is coming into play, why this was -1 and why this was a x plus 1. So what makes this divisor 0 is -1. All right, that's going to be what we divide by. We're going to bring down the first coefficient, and I'll show you those steps here. So when we do synthetic division, you probably already did it in Algebra 2. But what we're going to do is we're going to write a little box like this. And what makes this thing that equals 0 is -1. And what we're going to do is we're going to deal with the coefficients. We're going to write all the coefficients in descending order. If they skip a order, so like say they didn't have an x squared here, we have to fill that box in with a 0. We have to have all of those. So this first one is going to be 2. This will be 1. This will be -4. And this will be 3. They didn't skip any, so we don't have any zeros. The first thing we do, we bring down a 2. And what we do is we multiply these two guys. So we multiply a -2, or a -1 and -2, and we bring it up. Okay, so 1 and -2. So far we're there. We multiply the first coefficient, write the product under the second coefficient, and then we add. All right, hopefully that didn't disappear. It did a little bit. Let me screw down. All right, so we add these guys. So 1 plus a -2 is a -1, and then we go ahead and we repeat. 1 times a -1 is a +1, and add, which would make this a -3. 1 times a -1 times a -3 is a +3. 3 plus 3 is 6. That is our remainder. And here is our polynomial that we were left with above. You can rewind the video and go and check. This is going to, now since we're dividing, this is going to be 1 degree lower. So this is 2x squared minus x minus 3 with a remainder of 6. And that's what we had last time when we did this. So I'm just showing you synthetic division to make this a little shorter. So if you want to write those down, these steps, you definitely can. You can pause the video. I'll go slow so you can make sure to get all those guys there. So you can pause the video and write those things down. All right. So we're going to do one more so we make sure we know how to use synthetic division. Use synthetic division to divide m to the 5th minus 3m squared minus 20. It's in descending order, but notice they skipped a few on us. We don't have an m to the 4th power, we don't have an m to the 3rd power, and we don't have an m power. When we get to that point, when we're writing our coefficients out, we're going to have to fill those in with zeros. So again, we're going to divide by what makes our divisor here 0. So let's make a little box here. What makes that 0 is going to be 2. All right, and starting with x to the 5th, I have a 1. We don't have an x to the 4th, so I have to fill it in with a 0. We don't have an x to the 3rd, so I have to fill it in with 0. We have an x squared, so I need to fill that in, my -3 in. We don't have an m, so I'm going to fill that in with 0, and then I'm going to fill in my constant, which is -20. And so now we're using synthetic division. We bring down our first term, which is 1. We multiply these two, so 2 times 1 is 2, and add. Add down, 2 times 2 is 4, add down. 2 times 4 is 8, add down, which is 5. 2 times 5 is 10, add down, which is 10. 2 times 10 is 20, add down, and it's 0. So we actually have a remainder of 0. You'll find out what that means here in a little bit. And if we wanted to rewrite the polynomial after we divided, we would have m to the 4th plus 2m cubed plus 4m squared plus 5m plus 10 with a remainder of 0. So that would be the new polynomial then. Okay, so moving on. Factor theorem says if the remainder is 0, just like in that last one, then the divisor is a factor. So instead of having to factor that whole thing out, if we can find something that goes into it, we know we have a factor of that equation. So if the remainder is not 0, then obviously it's not a factor. So they're saying without us factoring these things and going through that whole process, let's just determine if x minus 3 is a factor of the polynomial that they gave us. So they gave us this polynomial x cubed minus x squared minus 5x minus 3. They want us to determine if x minus 3 is a factor. Well, you can do long division if you want to. I'm going to go ahead and I'm going to use synthetic division. I just like that better. So we have x cubed, x. We have all the terms. We don't have to fill in with any zeros. Let's write our box and fill in with our coefficients. So 1, -1, -5, -3. And what has to be outside is what's going to make this 0, which is going to be 3. Bring down our first guy and multiply. 3 times 1 is 3. Add down, which is 2. 3 times 2, which is 6. Add down 1. 3 times 1 is 3. Add down, which is 0. Since it is 0, x minus 3 is a factor. Our resulting polynomial would be x squared plus 2x plus 1. And it actually turns out to be handy if we can find one of these. And since we know that x minus 3 is a factor, if we factor out the rest of this guy, we get to find all the factors. So if we figure out what multiplied to be 1, what multiplies to be 1 adds up to be 2, x plus 1 and x plus 1. So if we wanted to factor that whole thing, we'd have this along with this guy, x minus 3. And if we FOIL that all out, we would end up exactly there with what we started with. So just that was a little extra stuff that we hadn't got to, but that's where we're going. A depressed polynomial is a polynomial that has a degree less than the original polynomial. So what I was writing at the end after we were done is I was writing the depressed polynomial. And it says sometimes a depressed polynomial can also be factored to give you another 0, and that's what I did there. I just factored that thing as well. If they wanted you to find a 0, then you obviously have to set all those things in a parentheses equal to 0. So in that last case, it would have been x minus 3, and then I believe it was x plus 1 and x plus 1, right? So if we were looking for its roots, or if we were looking for its zeros, and it was set equals 0, we set each of these guys equals 0. So x minus 3 equals 0, and x plus 1 equals 0. And so for that graph, we would have two zeros at x equal to be 3, x equal to be -1, and we don't have to write this one twice. So that's it for tonight. Hope it helps. We'll see you in class.